Welcome back. We're going to look at arithmetic sequences next. Arithmetic sequences are sequences that have a specific pattern. So this is lesson 7.1. So arithmetic sequences have a specific pattern to it. So let's take a look at the examples. 6, 12, 18, 24, so on. Say -2, -5, -8, -11, and so on. So if I look at my arithmetic sequence, the terms are there in the sequence. So the terms that are next to each other, I call them consecutive terms. Consecutive terms. They are terms next to each other. So the consecutive terms, if I look at it, the pattern that I see is I'm adding a 6, I'm adding a 6, I'm adding a 6. The two consecutive terms, 6 and 12, the consecutive terms 12 and 18, the consecutive terms 18 and 24, they all have the same pattern to them. If I look at the second sequence that I have here, the consecutive terms 2 and -5, -5 and -8, -8 and -11, they all have the same pattern, which is subtracting 3. Subtracting 3 every time. So my arithmetic sequence, the consecutive terms have a common difference. They have a common difference. That's what I represented by a letter D, the common difference. So if the consecutive terms have a common difference, then I call it an arithmetic sequence. So the common difference here is +6. The common difference here is a -3. So it's either adding every time or subtracting every time. So that becomes my arithmetic sequence. So as we saw, sequences can be expressed as functions, and functions can have function rules written for them. So the function rule is nothing but an equation that relates the input and the output. It relates your input and the output. So for sequences, we could write two types of rules. One is an explicit rule. The other is a recursive rule. An explicit rule is the one that relates the term position n to the term value f of n. Okay, so it relates the term position to the term value. The recursive rule, on the other hand, it relates the term value that you're trying to find to one or more of previous term values. Previous term values. So that's my recursive rule. Let's write an explicit rule for an arithmetic sequence. The book gives you a formula to write the rule, but we need to understand how we got the formula, so you don't have to memorize the formula. So let's say I'm going to take a sequence that is an arithmetic sequence, and I'm going to write the rule for that arithmetic sequence. Say I have my arithmetic sequence n, f of n, 1, 2, 3, 4, goes on. It is 60, 80, 100, 120. I don't know what that number is. Until I know what the n is, I cannot figure that out. So I have 60, 80, 100, 120, right? So I can see clearly that this is an arithmetic sequence because the consecutive terms, they have a common difference. And we know that difference is 20 plus 20. So you have a common difference between the consecutive terms, so this is an arithmetic sequence. So I want to examine what's happening between the terms, and I want to derive the formula that the book gives. Derive the formula for the book, what the book gives. So I have my first term, it is 60. My second term is 80. My third term is 100. My fourth term is 120. Let's closely watch what's happening here with respect to our term values and the common difference that's going on here. So for the 60, that's where I'm starting with, so I'm not adding anything to it. I'm not adding any common difference to it. So when I go from my first term to the second term, I'm having my first term, that is 60, and I'm adding the common difference to it to get my 80, right? For my third term, I have this 80 right here, and when I go from here to here, I have to add another 20, right? So I have this, which is 60, plus I have a 20, that was from my previous term, and I have to add another 20. That's how I get my 100, right? So when I go from third to fourth, I have to add another 20. So I'm starting with my first term, I'm adding a 20, and I'm adding another 20, which will give me up to here, and to get here I have to add another 20. That's why I'll get my 120. So you're seeing that pattern there. So I want to generalize this pattern so that I can write a rule for my f of n. So in this case, if you look closely, I have that 60 and I'm not adding anything to it. All right, I'm not adding any 20 to it. I have my second term, I have that 60, which is my first term, and I have that common difference 20. How many times I'm adding the 20? I'm adding it one time. The third term, I have my first term 60 and I have the common difference 20, and how many times I'm adding it? 2 times. For the fourth term I have the 60, which is my first term, and I'm adding the common difference. How many times? 3 times. Alright, so I can keep on doing that to get my all the other terms until I reach my f of n. Can keep on doing that until I reach my f of n. Alright, so for my f of n, I would have that 60 and I will add my common difference so many times. I don't know how many times that is. So to figure out what goes in here, let's go back. So for the first term, I'm not adding anything. For my second term, I'm adding it 1 time. For my third term, I'm adding it 2 times. For my fourth term, I'm adding it 3 times. So every time I have my position number, I'm adding the 20, 1 less than my position number. For 1 it is 0, for 2 it is 1, for 3 it is 2, for 4 it is 3. So every time I'm adding it 1 less than what my position number was. So for f of 5, if you have to say what number it will be, I'll take that 60 and I'll add the 20 how many times? I would add it 4 times. So 60 plus 20 times 4, that will give you your 140. Alright, so how many times I'm adding it? I'm adding it 1 less than my position number. So for 5, this will become 4. For 4, this will become 3. 4 minus 1 is 3. So my explicit rule then becomes f of n equal to, this was my first term and this was my common difference. So your first term plus your common difference times n minus 1. Okay, so this is what you have as a rule in your book, as a formula in your book for your explicit rule. So f of n equals your first term plus the common difference times n minus 1. So in this case, the first term was 60 and the common difference was 20. So if you knew your first term and your common difference, you could write your explicit rule. So explicit rule, again, the first term is f of 1 plus t times n minus 1. So my first term plus the common difference times n minus 1. So that's your explicit rule. So if I have an arithmetic sequence, all I need to know is my first term and my common difference, and I can write my explicit rule. So the second thing we're going to do is write a recursive rule for my arithmetic sequence. Again, recursive rule, it relates your f of n with one or more of your previous terms. So let's take a look at our sequence again. My f of 1 was 60, f of 2 was 80, f of 3 100, f of 4 was 120. So if I look at it, what is the thing that I'm doing repeatedly? Recursive means repeatedly. So what am I doing repeatedly? I'm repeatedly adding a 20. So the recursive rule relates your f of n to one or more of your previous terms, right? One or more of your previous terms.